Thanks. Okay, so sequence is an ordered list of numbers. Order matters. Next one is a related word, which is a series. Can I get a thumbs up if that word sounds familiar from Math 3 or 3+?
No, this is a series. Oh, wait.
I see 1 or 2 thumbs up. So if you had Miss T, I know you heard this word. A series is a sum of the terms of a sequence. We take the numbers in that ordered list and we add them up together. Yeah. We're probably not going to get to series because we need to talk about all of the intricacies of sequences. We also need to talk about conic sections, and we only have class until this Friday. So we're a little pressed for time. When you take calculus, you will look at sequences again, and then you will look at how to find the values of the series, meaning how do I figure out what the sum of those sequences is. Yay. The other 2 words have to do with how we define a sequence. And we have 2 ways to define sequences. We can define them with an explicit formula or with a recursive formula. We'll start with explicit. So an explicit formula defines a sequence well, actually, let me take that back. Defines the terms of a sequence by location. Come on, pen. I don't know why this TV likes to crash during 4th, but it is always in 5th, rather. Sequence. Define the terms of a sequence by location. My little squirrel brain cannot remember what I'm thinking when my pen dies. An explicit formula defines the terms in a sequence based on the location that you are in that list of numbers. Am I the 1st term? Am I the 5th term? Am I the 100th term? If I know where I am in the list, the explicit formula tells me how to find the value that sits there. Most of the functions that we have looked at in pre-calculus function as explicit formulas for a sequence. And I could use them as such. They define a y value in terms of an x value, meaning if I know an input, I can figure out my output without knowing what happened before or after. You guys literally just came back from lunch less than an hour ago. Recursive, on the other hand, requires us to know what happened in the spot before we are now. So a recursive formula defines the terms of a sequence. And it defines the terms of a sequence based on the previous term. Meaning if I am sitting in position 2, in order to figure out the value in position 2, I have to know what the value in position 1 was. This one requires a knowledge of history. I have to know what happened before me before I can figure out what's happening now. Okay, so we're going to do an example of both types so that you can see what explicit and recursive look like. Yeah? So I'm going to give an explicit and a recursive that define the same sequence, the same list of numbers. So the explicit formula for this sequence is a n equals 2n minus 1. And sometimes you'll see a sub n written as f of n. You'll see function notation instead of sequence notation. The recursive formula for that same sequence is a1 equals 1, and a to the n equals a to the n minus 1 plus 2. So before we use those to write out the sequence, I want you to take about 60 seconds in your small group, and I want you to compare those two formulas. What do they have in common? What do you notice that's different? If I'm looking, how can I tell the two apart? So I'm going to give you about 60 seconds, and then I'm going to call on some volunteers to share. Okay, we're going to go around in order. We're going to have all our tables share. I'm going to start in the front corner. So Alex and Alan, what did you come up with? Similarities or differences? What do you see? Two brains, 60 seconds. You must have noticed something. What do you see? Ooh, good. So this guy has two separate definitions, whereas that guy only had one. Yeah, good. So recursive is always going to have a starting point and then a recursive piece. The recursive piece only tells me what this position looks like based on the last position, but doesn't tell me where it started. I need a starting point to build on. Where was the very first term? Because then the recursive piece tells me what the next term looks like and the next term looks like. But I need a starting value. Good. Aubrey, what else did you notice? What did your table see? Ooh, Good, so there's n minus 1 in both places, but they're serving different functions. Good, so this guy depends on not just n minus 1, but a to the n minus 1. Meaning previous term. This guy depends on the term number, depends on n. So explicit depends on where I am. Recursive depends on what the term before it was. Good. Did anybody else notice anything that isn't up there? No one wants to share today? That's okay. It's okay. The first two tables hit the big ones. So how I tell the difference. Explicit is always going to have an n or a constant. It should never have a to the n minus 1. It's going to have an n in it somewhere. Recursive should always have two pieces. One of them is a number. Where do I start? One of them is a piece defined in terms of the last term, the previous term, a to the n minus 1. You need both pieces. Good. So we're going to use those to build our sequence. So I have two choices. My recursive formula is nice. It tells me that in position 1, my value is 1. I know my list starts with 1. I also know that from my explicit formula. If I substitute in n equals 1, 2 times 1 is 2. 2 minus 1 is 1. So the explicit and the recursive should give me the same answer for each term. Good. Using the recursive, if I'm in position 2, I'm going to take position 1 and add 2, which gives me what? 1 plus 2 is 3. I check with the explicit. I'm in position 2. 2 times 2 is 4. 4 minus 1 is 3. Any guess what my next term is? 5. Come on, pen. After 5, 7, and then probably 9, and then 11, and then it keeps going forever and ever. Yeah, good. That 2n minus 1 for the explicit, or sometimes 2n plus 1, those are explicit definitions for odd sequences. Even is 2 times n. Odd is 2 times n plus 1 or 2 times n minus 1. Because odd numbers are even numbers and then 1 off in either direction. Good. Good. Yay. There were 2 types of sequences you've seen before. We're going to look at both of them. So we will start with arithmetic sequences. And what do we remember about arithmetic sequences from Math 1? I'll give you a hint. The sequence we just looked at is arithmetic. Adding, yeah. Yeah, good. You add a constant to get next term. We called that constant common difference. I'm not going to ask that you remember that. But yeah, we add a constant to get to the next term. And if we're looking at a function like y equals 2x minus 1, and we were to graph it, what kind of shape would we get? Y equals 2x minus 1. Linear. It graphs a straight line. Intercept of -1, slope of 2. Yeah, arithmetic sequences make linear graphs. Yeah, that was an example of arithmetic. Zeroth term is -1. We add 2 to get to the next term. Yeah, good. What other type of sequence did you talk about in Math 1? Geo. Ethan was there. Geometric sequences, yeah. Arithmetic sequences, we add a constant to get to the next term. With geometric, what do we do? Multiply, yeah. We multiply by a constant to get the next term. Every term is double the last term. I'm multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That follows this pattern. I'm multiplying by 2 each time. Any guesses what the shape of that graph would be? Drawing it correctly, what's the name for it? Starts with an E. Exponential. We just talked about it in our unit not too long ago. It's an exponential graph. And that number that we're multiplying each term by to get the next term, that's the base of the exponential. So if I'm multiplying by 2, it's going to be 2 to the n. And then its starting point would be out in front. Good. So an example of this would be an equals 2 to the n. Good. So what we're practicing in this unit, we're practicing finding the terms in the sequence given their formulas, either explicit or recursive. We're going to do a bunch of examples today. We'll do some examples tomorrow. Tomorrow we'll look at what a factorial is, because you sometimes see those in definitions for sequences. Yeah? Okay. All right, so for all the examples, we're going to do the same thing. We're going to write the first 5 terms of the sequence. All right, so we want to write the first 5 terms of the sequence defined by the formula Bn equals 2 times Bn minus 1, and B1 is equal to 3. So 5 terms, 1, 2, 3, 4, 5. We need to figure out how we're going to find them. We'll start with the easiest. Based on that definition, what is my first term value? 3. They told me. N is 1, B is 3. So the first number of my sequence is 3. What type of formula is that they gave us? Maybe. Is it explicit or is it recursive? Recursive. Very good. It has 2 pieces, not defined by n. And then the question is this a pattern we recognize? Maybe, maybe not. Let's find the next term. Based on that definition, how do I find my second term? I want term 2. What do I do? So formula says B2 should be 2 times, and then B2 minus 1 is B1. What was B1? 3. 2 times 3 is 6. Second term of my sequence is 6. And we're going to repeat. Same process. I want B3. That formula for B3 is 2 times B3 minus 1, which is B2. What is B2? We just found it, 6. 2 times 6 is 12. Without having to write out the work, can somebody tell me what my fourth term in the sequence will be? 24. Very good. We're just doubling. 24. Next one would be 48. So this sequence is 3, 6, 12, 24, 48. I think the next one's 96. Yeah, 192. Keeps growing. Good. Good. And somebody earlier said this was an arithmetic sequence. Looking at it now, does it look like it's arithmetic? No. What does it look like? Geometric. We were multiplying by 2 each time. Yeah. Yeah. Times 2, times 2. This is geometric. Good. Good. Well, let's try another one. So same process. We want to write the first 5 terms of the sequence. I'm going to set up the same pattern. First term, second term, third term, fourth term, fifth term. Looking at that formula that they gave us, is that explicit or recursive? Explicit, how do you know, Luis? Very good. This guy has the variable n, not a of n minus 1. Good. So this guy is explicit. Which means all I have to do is grab the term number, plug it in for n, and then find the value that the formula spits out. So a1 is going to be negative 3 times 1 plus 8. Which I'm pretty sure that's going to be 5. I see some nodding. Good. And then same thing down the chain. So the next one's going to be negative 3 times 2 plus 8, which is 2. Okay, good. And then negative 3 times 3. Bruno's found the pattern. We're subtracting 3, so the next one would be negative 4, negative 7. I hear an Good. What type of sequence is that? It's a familiar one. Arithmetic. This one is arithmetic. Yeah. Yeah. Minus 3. Minus 3. We are subtracting the same value each time. Okay, next two don't fit either of those patterns. We're going to look at 2 new patterns. Same idea. We want to write the first 5 terms. Write the first 5 terms. So we want to write the first 5 terms of the sequence defined by a sub n equals -1 to the nth power times n squared, all divided by n plus 1. Okay, so who can I pick on? Ellie. Ellie, is that formula for number 3 recursive or explicit? You can check with your neighbors if you need to. Recursive or explicit? You got to vote for recursive. Can I get a thumbs up if you agree with recursive? I see 1 thumbs up, 2 thumbs up, 3 thumbs up. I say it's explicit. But how do we know? That's the important part, because it's okay to make mistakes, but now we have to understand why we made them. So how do I tell the difference? And we wrote it down, right? And come back up here. Why is this thing so slow? It hurts my brain. How do we tell the difference? Yeah, 2 things. 1, I know that, boo. We will pick up where we left off on Tuesday.